Let's go.
Okay, everyone. Well, I'm Reen Visser. I look after forest engineering program here in New Zealand, and it really is my privilege to be able to host this particular webinar component of a series on automation in forest operations. I can say that it's been organized to have 3 sessions. So this is the second of 3 sessions. And the first session, we had presentations from Portugal, Canada, and Holland. And what we've got today is 2 presentations from New Zealand, as well as 1 from Brazil. I would straight away like to give a lot of credit to Angelo Demora, who's been coordinating. He was at Fibria. He's now currently engaging on a PhD project, but he's very ably supported by Rafael Cavalli, who's a professor at Padua University, as well as Ola Lindros, who we'll hear from in a minute or so. He's a professor over in Sweden. Just by the number of people who've registered for the seminar, there's 225 people registered. Some people may join us directly, but I think it just helps highlight or show the importance of the topic of automation in forest operations. Most industrialized processes are heading towards high levels of automation and will transition towards autonomous type operations in the near future. Forestry, especially forest operations, is a very challenging environment to integrate technology. And I think there's a real opportunity here to learn from each other. There's many new developments, and many of those developments require a level of cross-pollination, if you like, to get the best results. So it's really an opportunity for us to share some information, but really take an interest in what is happening in different parts of the world and actually learn from each other. So before we start the presentations, the format today is that Professor Ola Lindros will give a brief overview. So there's this new unit set up within the IUFRO organization specifically on automation, and he's heading that up. And then we'll step through the presentations and we'll finish off with an opportunity for people to ask questions of the presenters and to engage in dialogue. So at this point in time, Ola, the floor is yours. Please tell us a little bit about this new IUFRO unit that you've set up.
Well, I will not talk too much about the new unit, actually. I was more presenting the IUFRO and welcoming from the organizing section here. So I just want to highlight that this webinar is arranged by the IUFRO Research Group 3.1 and 3.10. So it's the pleasure of Professor Cavalli, the coordinator of Research Group 3.1, and of Angelo Mora, who are presented also, who do all the hard work with arrangements of the webinar, and of myself, the coordinator of Research Group 3.10, to welcome you all to this webinar on automation in forest operations. And before we start the webinar, it's my duty to say a few words about IUFRO. IUFRO, the International Union of Forest Research Organization, is a global non-profit, non-governmental, and non-discriminatory organization. It was established in 1892, and it has its headquarters in Vienna, Austria. IUFRO offers a global network for voluntary cooperation, and the network is open to all individuals and organizations dedicated to forest and forest products research in related disciplines. And IUFRO unites about 650 member organizations in more than 120 countries, representing over 15,000 scientists. 70 meetings are held on average each year, and the biggest of the meetings are the IUFRO World Congresses, which takes place every 4th to 5th year. The next World Congress will be given in 2024 in Sweden, so I hope I will see many of you here then in person. And you can join any of the 9 scientific divisions, and Division 3 is the one dedicated to forest operations. Within the 9 divisions, there are over 50 research groups, more than 180 working parties, and 10 interdisciplinary task forces. So I encourage you to join IUFRO, and you do that by getting in touch with any of the almost 700 voluntary coordinators of these units. And you can also take part in activities of IUFRO special programs, projects, and IUFRO-led initiatives. And you can find more information on the website, iufro.org. And naturally, you can also contact us who organize this webinar series. And with that, we will turn more to the webinars. And you have already been introduced, Rianne. So I was thinking about introducing you a little bit more, so we have more details about you. And you already mentioned your activities in New Zealand with the School of Forestry at the University of Canterbury. And before that, you have been also with Virginia Tech in the eastern side of the US and with the New Zealand Logging Industry Research Organization. And you did your PhD at Buke University in Austria. And much of your research has focused on steep slope harvesting, but the research has covered a broad spectrum of forest operations, including safety and environmental performance. But recently, like most of us, I must say, has been looking at the benefits of mechanization, technology integration, and automation. And you started by saying that I would say a little bit more about Research Group 3.10, but I think this scope of the webinar, that is really catching what's happening and the focus of that research group. So I will not go more into details of that. Instead, I will give the floor back to you, and it's a pleasure for me and for Professor Cavalli to do so and to continue with the webinar. Thank you very much.
Okay, thank you for those kind words, Ola. And I certainly can say that Ola is a very established researcher himself. He's done a lot of work in the space of integration of technology, and you will be presenting in the third of the webinar series. That's next month. That's correct, Ola? Yeah, so we can look forward to hearing from Ola directly in that third webinar series. So I'll go straight into it. So my presentation is on advancing automation robotics in the New Zealand plantation forest industry. As you can see here by the title slide. So I'd just like to say kia ora from the South Island here in New Zealand. You can see it's a very picturesque part of the world, but what I'd like to cover in my presentation today is the move, or our move from mechanization our move to mechanization in New Zealand plantation forestry. And I'll really focus on some of the research as well as some of the implementation that we have in terms of mechanization and moving towards the automation of our harvesting systems. And then I'll finish off with some of the future ideas as well as developments that we have in place. So as Ola mentioned, while I'm involved in a number of different projects, I am trying to present a little bit on behalf of a lot of the developments that we have in New Zealand. And as such, there's a lot of people who've either contributed directly or indirectly in terms of slides and or information. So I just want to acknowledge the people that have made a contribution to me being able to put this presentation together. So in terms of our plantation forestry, and really just to set the scene of where we're at and where we're moving to. So we are actually working in relatively large, mainly pine plantation type of states. So you'll see that in the foreground, we've got a fairly clear differentiation between the native forest that you see in the background there. That's not being harvested. We really are working with these plantation forests. And you can see that the common method that we're working to, the normal silvicultural method, is a 25 to 28 year rotation. And we're mainly working with the larger scale clear fell harvest at the end of that rotation, as you can see in the foreground. So you can see here, we have challenges in terms of steep terrain, in terms of access, as well as being able to harvest safely, cost effectively, as well as with regard to the environment, of course. We typically run larger scale harvesting operations. Most of them will do around that 300 ton, 3 cubic meters per day. We'll go into a little bit of detail in terms of what they look like, but what's perhaps also a little bit unique to the New Zealand environment that we're working in is that almost 80% of our total product, so it's most of it, over half of it goes directly in log form, And even a lot of the material that we process will have to go towards our export markets. So we're very focused on that. So having just given that overview, what I can also say is you can see that the New Zealand work environment lends itself to higher levels of automation because we are in such a structured plantation, private ownership, forest environment, where we have a lot of forestry companies that are very motivated to be cost effective and remain internationally competitive in that space. What I would like to mention is that we've come a long way. It's only 10 years ago that many of our operations had a very strong manual work component. So for example, on our flatter terrain, while we still do skidder extraction, 10 years ago, we had a lot of people, for example, working on landings. Most of our operations were manually measured. The stems that have been extracted were manually measured and then cut up by guys with chainsaws to create the logs. Some of those key drivers were lower cost, which we should say it's a perceived lower cost at the time. We had good access to labor and they were very good. And so it was cheaper to run 3 or 4 people on a chainsaw than it was to run one machine that's able to do that same level of work. The other thing is we didn't really have a lot of faith in the technology, and so we trusted our people more to actually get the value recovery and the accuracy that we wanted when we were processing our logs. In terms of steep slope operations, and 40% of our harvesting is on steeper slopes done with cable logging operations, like you see on the left here. And again, 10 years ago, a lot of manual components, so nearly all of the felling was done by chainsaw, motor manual, and a lot of the work was still being done in terms of extraction with the choker setters. So we had people on the ground setting those chokers to allow the extraction. And again, it was this driver of a low cost as well as greater flexibility in terms of the application of this system. So in the 10 years, you can say we started really in 2012. So in this last decade, we really have experienced a period of very sudden change. And one of the key drivers for that was removing our workers from risk. So really improving the safety of our operations, which meant moving these manual positions to mechanized and or more automated type operations. The other thing is what we realized we need to remain internationally competitive. And like in many countries around the world, labor is getting more expensive as well as more scarce. Fair to say that it was really very much driven by our forestry companies with the need to innovate and modernize that was really driving this mechanization, higher levels of automation. So the easy one was on our flat terrain was really moving towards this mechanized processing. Of course, we needed the right technology. You can see the Waratah, a relatively famous company from New Zealand. That's very successful, and you can see them working in our forest. And so it was really the adoption of that technology that allowed us to be successful in that transition. Here's a small video clip that hopefully will play for you. One of these technology things that was working before, but now it seems to be stuck. Really, this was going to be a small segment of drone footage that obviously didn't play. But what we've got now is basically 4 people and 4 machines. You've got a skidder, you've got a processor, you've got somebody fleeting and somebody loading out. So it's a very mechanized type operation that we have in our plantation forest. But I think one of the keys to adopting the technology is also that it really creates a platform for technology and technology application. So here's an example. It's called Sticks. It's a commercially available product, I guess you could say here, produced by Forest PhD or managed by Forest PhD. And it really is turning the data that we know we can get from our harvesters through Stand4D really into a database, but making sure that that information then is not just being stored, but also being presented back to forestry companies and or our contractors in a really useful way. So we've got online reporting. The companies who subscribe to the service can see their operations, not just get their daily volumes, but also know where the operations are working, as well as what they're doing. So here we've got a harvesting machine working in the forest. You can track it, but you also start to get into information on each individual tree that's being harvested, what the value is, what the size is, what the distribution is as we work our way through the forest. So one of the exciting opportunities about that is our opportunity really to start to link the harvesting and the information that we can get in our harvesting systems back into, for example, our silviculture. So if we can track what we're harvesting, what we're achieving in different parts of the forest, we can actually start to summarize this. This is work one of my PhD students, Alejandro Oliveira, now back in Uruguay, was doing. We're able to start creating effectively a heat map of where in the forest we're actually getting the better growth rates. So we have a plantation. They're mainly, it's a monoculture. All the trees are the same, but obviously they're responding differently to different parts of the site. So the exciting thing about this is that we start to able to create that feedback loop from harvesting and actually look at precision silviculture in terms of planting, spacing, fertilizer, and stand management. I think one of the big contributions that we've made in New Zealand is really the mechanization and higher levels of automation on our steep slope. So this winch assist equipment, I think we're probably all familiar with it. It's really a winch on excavators or on bulldozers that's really supporting that machine. You can see it on the right-hand side as it's moving down the slope. And so we're not just mechanizing the felling, that's how we started off, but we're actually also now able to bunch and really create greater levels of efficiency for our cable yarder extraction. And if we're shoveling, either again we can bunch or we can shovel all the way back to the road and go for a fully mechanized system. And so now already more than 50% of our yarder operations have this winch assist support. And what is interesting, I'm able to track costs and productivity. So we've moved from it actually being a cost only a few years ago to now having a clear increase in productivity and a decrease in cost based on our knowledge of this new technology and how to best implement it. So the mechanization wasn't just on winch assist, but we've also moved quite a lot in terms of our cable logging carriage technology. We've always had the mechanical grapples, as you can see on the left, but New Zealand's put a lot of effort into designing motorized grapple carriages that allows us to become fully mechanized. So we don't have people felling on the slope. We don't have our choker setters. Everybody's in a safe environment, and it allows us to do our harvesting in a very efficient way. One of the roles I have here is to actually track our costs, productivity, but also what I can get is our level of mechanization from a database. And you can see that, for example, the gray line, so that's the percent of felling that was done in a mechanized manner. Only 8-9 years ago, less than 10% of our harvesting was on steep slope was with mechanized, and now we're getting up to that sort of 50% of everything being harvested is mechanized. You can see processing, ground-based, 25-30% 8 years ago, and now we're well up over 90-95%. So the mechanization on steep slopes isn't just improving our cable logging operations, but we're also able to transition now with winch assist to ground-based operations. So we have a number of very successful skidder winch assist operations And most recently, we've also started to introduce forwarder winch assist operations. So we're moving away from cable logging, moving towards weeding. What's some of the next big things? So we've worked very much on the harvesting systems. You can see that this logging, so for a lot of our truckies, they have to throw chains, many chains over to secure a load. And you can see here an innovative way. So in this case, this is a mechanism to allow us to move, in this case, 6 chains up over a log without the operator having to throw them. So again, it's sort of innovations in this mechanization space that's improving the safety of our operations. Another nice example is our log storage at the port. A lot of our logs, all of our logs going for export have to be scaled in. So that's a very manual task. It creates a backlog in trucks, and it can also create a real backlog in shipping. So this is Glenn Murphy's work, as well as others as well. But now we've got computer vision, artificial intelligence, basically scanning all our logs come into the port. Very automated handheld solutions, as well as fixed frame solutions. So it's taking a lot of that manual task away and automating. I'll mention here Forest Growers Research. It's an entity, it's a consortium between industry and government. Worked a lot on mechanization of steep slope previously, and now the key focus is on really moving towards this higher levels of automation as well as autonomous operation. So you can see in this figure what the goal is perhaps moving forward. And I can say that there's already some nice achievements in terms of working with yards that are more automated than they have been previously, including autonomous type management systems that are being built in to allow these systems to operate without human intervention in the long run. You can see here, there's some visions around having autonomous loading, robotic sorting, autonomous fleeting. Now, all of these are key projects in the current sort of 7-year research cycle, and many of these projects have been started, but it's fair to say none of them have been finished yet. So I'll finish off with just a couple of slides in terms of, this was a student project that some of my students worked on, but we're obviously working on this autonomous forwarder space, really creating the technology for autonomous movement of our extraction machines, and that's allowing opportunities for new design. So it's really a great, this technology is a great opportunity for bringing more young people into our industry and getting them excited about timber harvesting. Another nice project that one of my students is working on, we've got a lot of bent trees, or trees we call it sweep. And so here, Perry Hahn, one of my final year students, is working on really that computer vision and being able to automate the measure of sweep just using video technology. So it's not a guessing game for the operator, but it is a technology application that's supporting the operation. Finally, you can see here tree-to-tree machines, so Richard Parker and others, going from the concept of a machine being able to move by itself through the forest, all the way to kind of building a prototype that's able to cut a tree as it moves from tree to tree through the forest. Pruning is a very manual task. And again, hopefully this video will play, but basically that's a drone. So I seem to be having trouble with the videos, but it's basically a small drone with a pruning shear on the front, and it's able to fly up, identify the branches, and able to cut the branches off. So the idea is to have a swarm of these units that's able to go through the forest and do the pruning for us. Okay. So in summary, we've pushed hard for mechanization. We've had a lot of success in a short period of time. And I think we've made a major contribution, especially on steep slope. We've got a really highly motivated industry, both forestry as well as machine construction. So we've got a lot of automation built in, but this autonomous operation is still very much the next step here in New Zealand. We're not there yet, but we're working hard on trying to achieve that. Okay, with that, I will finish my presentation. I think we're going to save the questions until the end. Yeah. With that, I'd like to invite Paul to jump in now, and Paul will give us a presentation. He's traveling at the moment, but it's really nice to be able to introduce Paul. He's a director of Teleoperation. What's neat is Paul is actually doing the work. He's out there in the forest industry. He's actually implementing a lot of this technology and know-how into our system. And so it's great to be able to hear from Paul, manages his own company, is actually doing the work out in the field. So Paul, the floor is yours.
Thank you, Reen. As Reen said, my name is Paul Milliken, and to my left here is Daniel Lambourne. We work in a small company in New Zealand called Applied Teleoperation Limited. We specialise in teleoperation systems, control systems and camera systems for forestry operations. So I'll try to share my presentation here. So I hope you can all see that. The presentation is on teleoperation and robotics for forestry. And the vision of the company, Applied Teleoperation Limited, or ATL, is to apply teleoperation and camera systems to create a safe and productive workplace. And we use the term teleoperation to refer to a system of remote control where the operator has video and audio so that the operator is in a virtual environment and able to control the machine through the virtual environment. So an overview of the presentation. The presentation will be limited to two types of systems that we sell and install. The first is a teleoperated anchor machine. So in New Zealand, it's common to use a machine, typically an excavator, as an anchor for a cable logging operation on the other side of the valley from the hauler. The second type of system is what we call our full teleoperation system. So this has been trialed on a winch-assisted Fala Buncher machine. Both of these ideas started from the Future Forest Research Steep Terrain Harvesting Program, which was completed several years ago. So the first of the systems is the teleoperated anchor machine. So in the diagram, in the picture, you can see a hauler on the right-hand side of the screen, and with a mechanical grapple, and on the other side of the valley is an anchor machine or a tail hold machine. So this system allows the hauler operator to move the anchor machine from the other side of the valley. So no one is needed on the opposite side of the valley on the left side of the screen as you see it. So here is a view from inside the cab of the hauler. On the top right of the screen, you will see, on the top right of the picture, you will see a screen which is video and audio from the anchor machine on the other side of the valley. And here is a view of the video. So we use 3 cameras on this machine. The front view is the main view, and the 2 inset views are a camera looking to the left and to the right of the machine. And the operator can change the camera view by using the triggers on the 2 joysticks on the console. This was the first commercial installation that we installed. We have another installation in near Christchurch in the South Island, and right now we are in a vehicle on our way to install a second system for the same logging contractor. So here is a photograph of inside the cab of the hauler. So you can see on the left, the operator console, where the operator can start the machine, control all the functions of the machine, enable the hydraulics, control the lights, the horn, and also control motion of the machine. And instead of using pedals to control the tracks of the machine, the pedals are controlled by thumb levers on the top of the joystick, on top of each joystick. So the left thumb lever controls the left track and the right thumb lever controls the right track. When the system is not in use, the console can be folded forwards in front of the operator, as you can see in the picture on the right, so that he can operate the hauler to extract logs. Here's a photograph of the machine operating near Christchurch in winter. On the top of the machine, there is a flashing light, and there is also a siren that alerts people in the area that the machine is being operated under remote control or under teleoperation. So no one needs to be on this side of the valley. The machine is moved by the hauler on the opposite side of the valley. So that brings me to the second system, which is what we call our full teleoperation system. So in this system, the hauler operator, the Fala Buncher operator will sit in a trailer or in a console in a cabin, and will operate the winch-assisted Fala Buncher from the console. So this means that the Fala Buncher operator is completely isolated from any hazards associated with operating the machine using a winch on very steep terrain. And here's a photograph of, on the left, the machine operator operating near Nelson in the South Island of New Zealand, with a virtual console, which is a replica of the controls inside the cab of the machine. So there are pedals and joysticks. So the environment is very familiar to the machine operator. And on the right, we can see the machine. There's no one in the cab felling trees. So on the left is a photograph of the trailer, and on the right hand side is a photograph of the interior of the trailer from a demonstration. This photograph was taken during a demonstration in the North Island where we demonstrated the system. This slide shows on the left the interface that the operator has to control the Fala Buncher. So this is a touch screen, and on the bottom left there are controls that allow full control of all functions of the Fala Buncher, starting the engine, enabling hydraulics, controlling the lights, etc. And on the bottom right hand side of the left hand image are the controls for the winch assist machine. And then at the top there is telemetry information for the operator, such as fuel level, temperatures, etc. The picture on the right shows the camera view when the camera is not operating, which makes the view clearer. So this is an overlay, which is normally overlaid on top of the view from the camera, showing an artificial horizon line. This allows the operator to understand the slope of the machine and to be able to level the machine to keep the machine on a suitable level to operate it. And the text disarmed at the bottom of the machine shows that the hydraulics are not enabled at that point. And the message video is not live shows that the camera is not transmitting video to the screen. So I've covered two different types of systems here. Firstly, the teleoperated anchor machine, which is used to move a mobile anchor, which is a very common method here in cable logging operations in New Zealand. This system we sell for 41,000 New Zealand dollars plus the cost of modifying the hydraulics. The advantages are the hauler operator can move the anchor machine, so no worker is required on the other side of the valley. We're on our way to complete the third installation of this type of system. The benefits are a reduction of the cost of labour. It also removes a boring job, and it's a job that's very uncomfortable, especially in winter, because an operator is not permitted to sit inside the anchor machine while the hauler is operating, in case the anchor machine is pulled down the hill. So this removes the need for a person to be waiting on the other side of the valley, often in the snow in winter. The second type of system was our full teleoperation system. We sell those on a case-by-case basis, as they're all can be different types of systems. The main advantage is it removes the operator from the cab of the machine, isolating the operator from any hazards or any dangers involved with being on a machine that is winch assisted on steep slopes. This type of system has been demonstrated as part of the Future Forest Research Steep Terrain Harvesting Research Program. And it was demonstrated in 2017 here in New Zealand. So the main advantages are it isolates the machine operator from the hazardous area and provides a comfortable working environment. For the future, we anticipate that this type of system will open the possibility of removing the cab from a machine and having a completely cabless machine. And it's also a platform for future automation. So we imagine that this will progress step by step with the automation of certain functions to help the operator. But the operator will still have oversight of the felling and bunching operation. Okay, so that concludes my presentation. So if there are, I'll hand back now to Reen, and if there are any questions, I'll answer them at the end. Thank you.
Okay, thank you very much, Paul. Really interesting presentation. Appreciate you getting the opportunity to present from your van. It really is a great technology that we're able to do that. Without any further ado, I'd like to move over to our third presenter. So it's Mark Gutierrez, and sorry, I think I've pronounced that very badly. Again, I'll let you correct that pronunciation as we start. Look, Marx has 25 years of experience in construction and mining, and after about 10 years at CAT, he's now at SciTech, and he's the general manager there. So the thing that he's mentioned, I must admit this is the first time I've met Marx, but for the last 5 years, he's very much focused on automation, network, teleoperation, as well as developing new solutions for different markets in this particular space. When I introduced it, the topic, I did say we should look across, and it's not just to other regions, but in this case, we're looking towards another industry. So most of Marx's experiences in the mining industry, and I think we probably all recognize in forestry that mining has been ahead of us in terms of the implementation of automation. So we look forward to your presentation, Marx. I'll hand it over to you.
Okay, thanks, Fran. Guys, good morning, good afternoon, good evening for some. I don't know exactly. I'm here in Brazil. Here's 6, almost 7 p.m. The curious thing here is because what I'm going to share with you guys, we started here in Brazil looking for the forest application. But unfortunately, after some bad events in mining markets here in Brazil, we changed our focus and we went to develop this new things for mining. But one thing is it's good that it's a pleasure to be here and to talk with you guys. I'm an enthusiast for the forest applications. So I'll share my screen. Okay, share some. Can you see my screen, guys, please?
Yes, we can see your screen fine.
Okay, good. Just a short introduction. I'm working Cytec Brazil. Cytec is a brand created by the joint venture of Caterpillar and Trimble as well. But we are not only a Trimble distributor nowadays in Brazil. We distribute reagent, we distribute Trimble. And a couple of weeks ago, we started to develop our own solutions, okay, looking for such different markets, such as mining, ports, construction, okay. And so we start to add some other brands in our portfolio, and I can show for you guys some of those brands. But the thing is, we work to innovate the business. Okay, here in Brazil, talk about technology, the really hard task here. We have a so old-fashioned way to do everything here in our country. I think forest application is about 10 years ahead of other markets here. But when we're talking about mining and especially for construction, we are, I don't know, an entire century behind all the other countries. And I think in New Zealand it's the same. You are very far ahead of us in those kind of applications. But yeah, why we are here? Okay, we are here by the security. Okay, as I told you guys, we have some bad events here. I know if you heard about some dam collapses here in Brazil a couple of years ago. It was really bad, and we were challenged to create a kind of a solution, not only a product, but an entire solution of Engineer 4.0, focus on security, but without forget about cost reduction, accessibility, and of course innovation, because we had to create something completely new to do this task. And what is that? What is this damn project? Some of people used to say "goddamn project" because it's a mess. But what is this damn project? Nowadays here in Brazil, we have more than 50 dams at risk of being collapsed in Brazil. Okay, and all those mining companies do something to reduce this risk. Okay, so we have about 50 potential risk of collapsing here in Brazil. And there is two ways to do this. It's the material. There is a process number one, material removal, or the process number two is the classic process. Okay, both process, it's a really critical, is in a really critical situation and a very hard task. Why? Because they ask us to do this without people on the field. This is the rule number one. You have to create a method, a process, an entire 4.0 engineer process to do this job without having people inside the dam, okay, or inside the area. The red, they call the red area, is the area of risk. So we start to think we have so much time. We had about 6 months to do this, okay? So we start to call to Trimble, call to reagents, to look for different suppliers, to talk with Caterpillar, to talk with our customers who used to work inside mining applications. So we start to think how we can handle with this challenge, okay? So we start creating this process. It's simple, but very, very hard to do it. Number one, install an infrastructure for the service. What I mean install reagent radios, okay, to make the connection between machine and the operator. Once I can't have operators inside the machine. And this video is interesting because we used to use wrapper rope to install the radios inside the risk area. After that, we started to use drones, okay, with propeller solution to do the survey of the area. After that, we modeling the project. We installed this project on board on the machine. And after that, we do the as-built, okay, during the 360 of this method. Everything without people inside the dams. And how we can do this? We create one solution, join together propeller, the drone, the flight drones, the Trimble solution, reagent solution, and Naval solution. What is Naval? Naval is a local supplier. It's a company who used to do remote controls. We get those remote controls and start to study how to apply on these remote controls more technology, more intelligence. So for the first time in the world, we create a remote control that you can turn on or turn off the Trimble 3D solutions. Okay, and this was the point of change for us, because to have to only transport material from one side for the other side, it's easy. You can do it in autonomous trucks, for example, or autonomous excavator. But this is not the case of just transport material. You have to do an engineering. You have a code, you have a grade, you have some risks that you have to avoid. So we add Trimble, reagent, Naval, and propeller solutions all together. Okay, as you can see in this video and looping, you will see a big white box. We developed this shelter, so all the operators will operate those machines inside those shelters. Okay, and then you can see right now. So in this shelter, we have the radio connections in that mast, and we start to operate the machines over this shelter. But after some months, our customer starts to ask us for more, because the solution works very, very well. So as I said, the challenge never ends. And after a year of study, we had more than 125 cameras connected, 27 reagent radios working together, 8 signal repeaters like this one at the bottom of this speaker, 5 operation shelters, and 18 equipment working together. In the past, before this project, the market machine market and the automation market used to say that only until 8 machines can work together at the same network. But nowadays we have 18 in this operation and more 12 in another operation far from our city to 200 miles, about 200 miles. And the biggest challenge was the communication network. Okay, have those all of those cameras working together without lag. Yeah, because the operator should know exactly what the machine is. The operators start to claim about the lack of sensibility, because on board the machine you can see if the machine is going to go for one side or for the other side, the inclination. So we develop some inclinators that you will can see in other videos in a couple of slides ahead, trying to get more sensibility for the operators. And 2 years later, that's what we have. We have transmission by IP, all the controls of the remote control transmitted by the IP protocol. We have the machine panel with right precision system by CAN port. Okay, this is the Trimble 3D on the screen. Those are the inclinators that the operator can see if the machine is going turn to right, to left, and front or back. More in these, we have the, as I said, the total remote trigger of the 3D system from Trimble. One big challenge at the beginning of this project, we used to use one software from the market to manage all the cameras, all the image. But after we start to add so many machines and so many gadgets at the project, such as the collision radar, cameras for back with assist, and other things, the camera software doesn't work very well. So what we did, we started to develop our own software. So we developed 100% internally. The Cytec View is our software to manage the cameras. We designed an intelligent cockpit with fast hitch. You can change the different kind of machines in 30 minutes. Okay, you can. I'll show to you guys the cockpit. You can use a cockpit with an excavator, for example. In 30 minutes late, you can change it for a truck tractor. Okay, for a D6, for example. Okay, the RPM audible and visual alert. The operators start to claim about the sound of the truck, especially for the truck. We use Mercedes-Benz trucks, and they start to break some not the engine, but the transmission of the trucks. So we create one signal with a voice telling them that they're over speeding, they're with over RPMs, to avoid them to not break the transmission. The operator presents sensor. If the operator leave the seat, the machine stop to work. Okay, as I said, integrating inclinometers and no brake for hardware network. Okay. And what's happening now? There is our customer, as I told you guys, our customers start to ask us for more and more and more. In the past, and at the beginning of the project, we start to operate the machines inside the mining at the shelter. But the customer says, I would like to take the operators out of the mine. So what we did, this is a building in our city, okay, far from the mine, more than 15 miles. when we have all the operators operating those 18 machines. Look at this video. We are inside the city, okay? This is in this building. As you can see out of the window, you'll see some buildings in the middle of the city, okay? And this is the place that the operators are operating the entire site, okay? This is a mixed solution of cable and full mesh. Customer passes the cable from this building until the mining site, and we did the connection with the radiant radius. And in this other video is our cockpit for the truck, okay, at the same building, okay. This guy is here, okay. And next week, we will launch the cockpit for the excavator and the truck tractors in this operation. This is really incredible. And just to end, this is a short video about the entire project. We named this solution as LIVE. Okay. LIVE means lifeguard vehicle. That's it. We did this short video with some images from one of the sites that we're working nowadays. This is the site with 18 machines. In general, the operator can be wherever you want. Okay, if you have internet connection, you can operate the machines. Look, the entire site without people. And of course, I'm talking about mining application, but nowadays we have two forest players here in Brazil asking us for this solution. One for excavator, okay, and another one for wheel loaders. This is the old system with PLL synthesized. Okay, that you can see we had in the past a camera looking for the Trimble control box, and now this is the new one that we have. They already have the control box on screen with our video software. Everything working together, zero accidents in more than 24 months. So that's it. Some of applications and advantage. We can use LIVE for, of course, for the commissioning and adjustment of dam at risk, dredging with amphibious equipment, forestry, and vegetation suppression. One of the customer that asking us for the excavator is for vegetation suppression north of Brazil. Handling of radioactive materials. We have a customer here in country. He works in a radioactive sector, so he handled with radioactive rejects, and he used our automated solution to move those materials. Ship hold cleaning, we have in 2 ports here in Brazil. Removal of improper materials in crushers, we have it in one of the largest mining companies here in Brazil. Steel operations, as you can see in this picture, and wagon handling and more. Every day we are looking for more application for this solution. Guys, that's what I would like to share with you. Thanks. Unfortunately, it's just 20 minutes. I would like to talk a little bit more, but there is my contacts. If you want to send me mail, notes, WhatsApp, whatever, it will be a pleasure to share with you our entire experience. Okay. That's it. And thanks for the invitation, Angelo.
All right, thank you very much, Marx. Really enjoyed that presentation, and especially there's obviously a lot of synergy there with what you're achieving as what Paul has achieved, especially in terms of the challenges, but what you're certainly doing has scale, as well as perhaps linking back to my presentation is, you know, that is the vision of our industry is actually to have these opportunities in that teleoperation, higher levels of automation. So it's really applying that technology that you're successful in mining and applying that to the forest operations sector. So very good. We are encouraged to send the questions via chat. So if you do post them on chat, we will just spend a little bit of time working our way through the questions. So a question actually from one of my students, I think, to Paul, awesome bit of technology. Do you need a clear line of sight between machines for your system to work?
We do use it is easiest when there is a clear line of sight between the machines, which is simple for an anchor machine, for a hauler. There are two options if there is no clear line of sight. One option is a repeater or a network of repeaters, such as the Radiant networking system that Marx spoke about. Another option is to use a different frequency that can operate out of line of sight. In New Zealand, the restrictions are quite severe with regards to suitable frequencies, the use of suitable frequencies for unlicensed users. But in other parts of the world, this is easier, and this is definitely a possibility. So we have done both, and we have both options, and we would look at whatever option is most suitable for the application.
Okay, thank you for that. One of the first questions was with regard to silviculture practices. So that's for my presentation there. So that's from Ario Samuel, Dr. Ario Samuel. And so in New Zealand, we're now plantations. A lot of our stands might be in that 8 to 10 hectare type space. So what we typically have is information at that stand level. And we tend to apply our silvicultural practices in terms of planting spacing, but also our fertilizer application or our spraying application based on the stand. So the idea here is to really go from that 8 to 10 hectare working space to moving towards more precision forestry, so we can actually adjust our fertilizer and or our spraying to perhaps the sub 10th of a hectare type space, really move towards that precision forestry. So that's what we were referring to there. So question for Paul, apart from steep areas, do you feel that your technology could also be applied to waterlogged areas, to swamp type conditions?
Yes, definitely that it could be applied to that application.
Okay, great. So to a question to Marx, did you face any training barriers with the operators, or what's the perception, especially from the younger operators? You presented very nicely that you've moved from the mining site, now you're in the city in terms of your operators. What was your experience there to get the younger operators to be in a building instead of being out on site?
Yeah, at the beginning we faced with some issues because old operators starts to be more confused about the solution, you know, And what we did at the beginning of the project, we create a training center, okay, in a different area outside of the mine, and we train 45 operators, most of them young. It's funny because we used to ask for them, do you like video games? Yeah, okay, come and join us. Because this kind of people that who has more synergy with technology. So we have barriers, especially with the lack of the sound of the machine, okay, and the movement, the inclination movement of the machine. The sound, what we did, we transmit the sound by earbuds, okay, for the shelter, and we create the inclinometers, okay. But of course, this is a barrier. But nowadays we have about more than 100 operators well trained on this solution, okay.
Thank you, Mark. And while you're explaining some of those aspects, I saw Paul and Daniel nodding their heads because I know that they've also had to put those type of what we call haptic feedback type systems into, in terms of the sound, but also in terms of the feel, so that the operators are more comfortable operating in a tele format as opposed to in the machine.
Yeah. Nowadays they love us because they don't have to go more for the site. Okay, they are about 20 minutes at home. This is very good.
So it's really interesting because a lot of the things you've presented are things that we've discussed here in terms of the implementation. So those challenges are common, I think, across, specifically with regard to maintenance. So it's one thing to have the operators off site, but the question was, how do you do your maintenance, refueling? So do you have a few specialists left on site and the operators somewhere else, or how do you manage that part?
Very, very good question. For sure, for refueling or for small maintenance, we have to take out the machines from the risk area, okay, and get the machine in the blue area. We call blue area is the area outside of the dam. But one problem is sometimes the machines break inside the area. Okay, and it's happened. So together with the customer, we design one special ripper that they can clutch the both rippers together, and they pull out the machine from the area. This is one completely mass operation because you mess with the undercarriage of the machine. Okay, you bring a lot of damage of the machines, but it's better than stay with the machines inside the area risk. Okay. Sometimes when we have a kind of how can I say the tubes that pass oil. Help me, Angelo.
The hoses. Hydraulic hoses.
Hoses. Sometimes when the problem is just a hose, the helicopter go with the mechanic with a wrapper rope down to the machine, change hose, and let's work together. Let's work again. Okay, but it's a very, very hard task.
Mark, so a question from Ola Lindros there is, do you have LiDAR on your machines to avoid collision, or how do you avoid the machines driving into it?
Well, yeah, we have LiDAR solution from Brigade. I don't know if you guys know this company. This company is from England. We add Brigade LiDAR collision alerts, okay, to avoid collisions between trucks and machines and trucks, okay?
Another question there is around costs. So I guess what I mentioned, it was nice for us to be able to track costs that when we first implemented the full mechanization on steep slope, there is some real additional cost as people adapt and really start to work, but you need to have some pain to get the long-term gain. We've been able to track that. So Marx, are you seeing the same thing? So I mean, I appreciate the primary objective is to remove people from harm, but in the long term, do you feel that operating the teleoperation more autonomous will be more cost effective than actually having the operator in the machine?
Perfect. As I told you guys, we don't have a case study inside forest application, but in my opinion and the opinion of both customers that are asking us for this solution, they lost so many time bringing the operator from the base of the company until the field. Sometimes it's those distances too far. So they're trying to make this operation of far distance, trying to reduce this transport time that they lose when the operator starts work at the gate of the company until the place that machines are, you know. This is one thing that we start to study nowadays. But the main purpose of this project, again, is not cost, but it's safety, security.
Okay, thank you. Yeah, and that's certainly a big driver for our forest industry as well. And that question was from Alejandro in Uruguay. So now we've got another question, perhaps to both Paul and Marx, is, so Marx, it was directed at you in terms of, you've been able to achieve this in a mining environment in Brazil. Obviously, you've got the resources, you've got the money, you've got the interest. But the question is, you know, the connection systems are a bigger challenge in the forest industry. So do you feel do you feel that you'd be able to apply what you've achieved in mining in a forestry environment? And then I'll ask Paul to comment after you.
I'm reading here about the canopy error, particular problems in our sector. Regent is working so close with us in this project, and they are developing some new solutions for us to increase the connectivity. And we have two solutions that we're studying nowadays. One is a drone. A drone is a cable drone that they have some batteries to keep this drone flying, okay, providing connectivity. And the other solution is a balloon. It's a balloon, cable balloon, okay, with Regent radios providing a network for the machines. But I hope, guys, next year, for example, we can have another meeting like this one, another event like this one. And I hope I will share some good news about forest applications.
Okay, thank you. So Paul, you've mentioned about the line of sight, the direct. So how far are we away, do you think, in New Zealand from a company like yourself being able to provide a teleoperation solution where you've got your people in the town, in the city, your operators, and operating the equipment out of the forestry, the rugged forestry environment?
We could do that now. We have used Regent equipment in the past with some of our installations, and we've also we've used a variety of different types of communications options. So it is challenging, but it is possible, and we would select the solution depending on the application.
I think also the crew, you would have to skill up the crew on managing moving mobile antenna plant and stuff like that, because they're moving all the time. And as soon as they got used to that piece of equipment and learned how to use it effectively, it just became part of their tool set. So I think it's totally possible. Yeah.
Very good. Yeah, I think Mark, somewhere in your presentation, you said the challenge never ends, but of course the opportunity never ends as well. And so that's the exciting thing about this technology integration in our space. Perhaps moving towards the last couple of questions, and here's a nice one to perhaps head towards the end, but Mark, based on your mining experience, so this is from Renato Tan, could you share your vision of remote operations in forestry? So I guess where would you see us heading in forestry based on what you know in mining?
Good. In my opinion, I can say more about our country here. I don't know very well what's happening in forest application. Including I'm learning here with the two first presentations a lot, and it was very nice presentations. But in Brazil, I think it's a point of no return. Okay, use this kind of remote operations, including in forestry, to increase the safety, to increase we are talking a lot about ESG things, you know, to reduce fuel consumption, to reduce the risk, to give a better environment for the employees, and of course with the advance of innovation of technology, we're going to provide more efficiency for those applications. And honestly, I think in 2022, we're going to see some remote operated machines in forest applications here in Brazil. Okay, and I'll be really, really happy to share with you guys some news in a couple of months. Just give me a couple of months.
Excellent, yeah. I'm sure there's lots of regions that will have new developments as well, and we can really look forward to the next couple of years. So if there's any more questions, do post them on chat. Otherwise, I do appreciate it's well after midnight already for all of our European colleagues that have zoomed in. It's 10 o'clock in the morning here. I think it's 6 o'clock in the evening in Brazil. So it's a very international time space we're working across here. But otherwise, if there's no more questions, Paul, Marks, anything else you wish to add? Otherwise, I think, Angelo, it's an opportunity to kind of wrap it up. I think it's been an interesting, really, really good session, especially to see that technology really being applied out in the forest industry. I can make a plug, so I believe the third part of this webinar series is scheduled for the 20th of October. There will be a series of presenters from Sweden, led by Ola himself. And I know that Sweden has done a lot of in technology automation, so that's really something to look forward to, as well as another presentation from Brazil. So Brazil is also obviously a powerhouse in the application of these technologies. So great to see.
Yeah, and if I mind to interrupt, I can just give you a short teaser. We're gonna demonstrate this machine driving into the forest, finding logs and loading them all by itself, 6th of October. So hopefully we can give you some successful footage from that demonstration. So it will be a very interesting time for us to really show a proof of concept. A little bit simplified, of course, but actually to do those kind of things by itself, not pre-programmed, but actually finding the logs and do it with the crane by itself. It's going to be really exciting for us if we are able to pull that off, which we, of course, think we can. So don't miss the next webinar.
Absolutely, that's a great little teaser there, Ola. That's a pretty neat looking machine, and I know it's a little bit of the holy grail in terms of this picking up, finding the logs, picking them up autonomously. That's It's a challenge, but it looks like you're close to cracking that. So that's a great development if you're able to achieve that. Yeah. So sorry, is it 20th or the 6th? What's the, sorry, Angelo, what's the next date for the next webinar, Ola?
Hang on, it's the 20th.
It is the 20th, sorry, yeah. So it's the 20th of October. I think most of you are registered. Okay. Otherwise, so on behalf of Angelo, who's done a lot of the work to coordinate this, Rafael Cavalli, Professor of Padua, Ola Lindros, myself, and co-presenters there, Paul in the van, somewhere in New Zealand, as well as Mark's over there on holiday in Brazil. Thank you very much for zooming in. Yeah, and we look forward to seeing everybody in the third and final session of this webinar series on automation of forest operations. With that,
thank you, Professor Rian. Thank you all for your the presentations and for the audience to join us until the end. Thank you so much, guys, and we look forward to see you again in the next one.
Likewise, thank you very much.
I hope you're doing safe. Bye-bye.
Thank you. Bye-bye.
Bye-bye. Ciao.
oh.